Hey guys, welcome back to Eureka, and in this video I'm going to be teaching you the last three rules of the derivative: the product rule, the quotient rule, and the chain rule. So let's start with the product rule. It states if you have a function f of x which is equal to another function g of x multiplied by another function v of x, the derivative f of x or f prime of x is equal to the derivative of the first function multiplied by the second function plus the derivative of the second function multiplied by the first function. Okay, so this simply means if we have a function y is equal to, let's say, 2x multiplied by x squared, well, instead of simplifying, you can use the product rule and you can say 2 multiplied by x squared plus 2x multiplied by 2x, right? The derivative of the first multiplied by the second, and the derivative of the second multiplied by the first, right? Well, yeah, in this video I'm going to be proving it using the simple derivative formula. So from the last video, if you guys remember, if we have a function f of x, then f prime of x, or the derivative of x, is equal to the limit as delta x goes to 0, f of x plus delta x minus f of x over delta x, right? Now we're just going to be substituting. We defined f of x to be g of x multiplied by v of x, right? And so we can define f of x plus delta x to be equal to g of x plus delta x multiplied by v of x plus delta x, right? So we're going to substitute into the formula both of these, right? So we're going to get f prime of x is equal to the limit as delta x goes to 0, g of x plus delta x minus, v of x plus delta x minus g of x multiplied by v of x all over delta x, right? Now I'm going to manipulate this. Let me just write v properly. I'm going to manipulate this. And what I'm going to do is I'm going to add two terms. You know, if I add plus x and then I add minus x, it's like adding 0, right? So I'm going to do the exact same thing. So what I'm going to do is I'm just going to be like limit delta x goes to 0, g of x plus delta x, v of x plus delta x, minus g of x multiplied by vx plus delta x. And since I subtracted one, I have to add the same exact thing, x plus delta x. Now you might ask, why did you do this? You just added 0. Well, you know, because this from here to here is just equal to 0, right? You're just adding the same function all over delta x. So what this allows us to do is it allows us to split the fraction. So what we're going to get is the limit as delta x goes to 0 as. So what happens to this term? We can factor out v of x plus delta x, right? Let's factor it out. We're going to be left with g of x plus delta x minus g of x, right? And what's going to happen to this term is the exact same thing. You can factor out g of x. So yeah, so let's factor out g of x. You're going to get g of x multiplied by v of x plus delta x minus v of x, right? All over delta x. So what can we do here? We can split the fraction and we're going to be left with v of x plus, actually, let me just shift to the right here. Shift to the right, economics. Anyways, v of x plus delta x multiplied into g of x plus delta x minus g of x, this over delta x, and of course we have the limit, plus g of x. All I did was I just split the fraction. Simple mathematics, right? Over delta x. Well, now what we can do is we can redefine this as v multiplied by x plus delta x. And what's this fraction? Well, this is just the derivative of g. The derivative of g, right? From the last video, you know, the limit applies here and the limit applies here. So this whole thing is just v plus delta x multiplied by this whole fraction and the limit. So this is going to be the derivative. Plus, same thing applies here. It's going to be g of x multiplied by this fraction, which is also the derivative of v with respect to x. And there you go. It's proven. Let me just write it in a neat way. That means it's we still have one more thing to do. Let's just scroll up a bit. So this becomes v of x. This becomes v of x. Now let me tell you why this becomes v of x. We said that the limit as delta x goes to 0, right? So delta x becomes very, very small. Very, very small, like 0.0001, 0.00000001, or any other smaller number. So we can ignore it. This is exactly what we do. We say that delta x tends to 0, so delta x disappears, or delta x becomes 0. Although it doesn't become 0, it becomes very, very close to 0. So our end result is f prime of x is equal to v of x multiplied by g prime of x, right? This means g prime, plus g of x multiplied by v prime of x, which is exactly this. And there you go. That's the product rule proven. Let's do some examples for you to understand. Let's leave the formula up here. Okay, so let me give you an example from the book. Example 1, page 50. Y is equal to x cubed plus 2x multiplied by radical x. They're telling you find the derivative of y, find y prime. Well, let's use this, and let's say that v of x is equal to x cubed plus 2x, and let's say that u of x is equal to radical x, right? V prime is equal to 3x squared plus 2, right? And u prime is equal to 1 over 2 radical x, yeah? This is just using the simple derivative rule. Taught this in the first video of derivatives. Check it out, it's on the channel. And all we're going to do is we're going to substitute into this equation. So we're going to need v of x, so it's going to be x cubed plus 2x multiplied by g prime of x, or in this case u prime of x, which is just 1 over 2 radical x. And then we're going to say plus g of x, v prime of x. So it's going to be 3x squared plus 2 multiplied by radical x, right? And this is your answer. Now, what you can do is you can simplify, but that's up to you. If you want to simplify, this will probably simplify into a very small equation. Good for you. Let's do another example just to make sure you guys understand. Okay? So let's just change the color because it's starting to annoy me. Let's go for guess this, or probably, yeah, red is good. Okay, let's do it. So let's take another example. Let's take example number 2. Y is equal to x squared plus 1 multiplied by 1 minus radical x, right? Now they're telling you find the derivative of y. It's going to be equal to this function multiplied by the derivative of this function, which is just minus 1 over 2 radical x, right? Plus this function multiplied by the derivative of this function, right? This is your answer. You're going to start getting these types of questions in the exam, and you need to be faster than lightning. Like, this has to be done mentally, okay? And derivatives are pretty easy and they're pretty fun to do. Now we're going to start with the second rule, the second most important rule, which is called the quotient rule. If you have a function f of x and it's defined to be g of x over v of x, then f prime of x, which is the derivative, is just equal to the derivative of the first function multiplied by the second function minus the derivative of the second function multiplied by the first function all over the denominator squared. Okay, what I'm going to be doing is I'm going to prove it. So yeah guys, let's continue. So I'm going to be proving it. So we know that f prime of x is equal to the limit. I'm just going to write the limit definition again. And of course, the derivative will always be proved using the limit function, okay? Or the limit definition of a derivative. So let's go. So f of x is this, right? So what's f of x plus h, or f of x plus delta x? Well, it's equal to g of x plus delta x over v of x plus delta x, right? So I'm just going to substitute. So we know this is just f of x plus delta x minus f of x all over delta x, right? I'm just going to substitute. We're going to get limit as delta x goes to 0. And g of x plus delta x over v of x plus delta x minus g of x over v of x all over delta x, right? We just substituted f of x and f of x plus delta x. Now, I'm just going to simplify this really quickly. What we're going to get is limit as delta x goes to 0. So we cross multiply and then we multiply by the denominator. You know how to simplify a fraction, right? So we're going to get g of x plus delta x multiplied by v of x minus g of x multiplied by vx plus delta x all over their common denominator, v of x plus delta x multiplied by v of x, right? All over delta x, right? Well, now I'm gonna again manipulate this function. How am I gonna manipulate it? So I'm gonna again add some weird coefficient that turns into a 0, right? So I'm gonna subtract g of x, v of x, and I'm gonna add g of x, v of x, okay? And yeah, minus gx v x plus delta x, right? So here I added 0. This is exactly what I added. Over v of x plus delta x and v of x. And all of this is divided by delta x. If all of it is divided by delta x, what we can do is we can actually take this delta x and put it in the denominator here. Good. Now, what we're going to do is, again, we're going to split the fraction. And what we're going to get is g of x plus delta x, and of course there's the limit. So g of x plus delta x multiplied by v of x minus g of x v of x, right, over the denominator, which is vx plus delta x v of x multiplied by delta x, plus, we're going to split this as well. So we're going to get gx vx minus gx vx plus delta x over vx plus delta x multiplied by v of x multiplied by delta x, and there's the limit. So here we can obviously factor something out, can't we? We can factor out v of x, right? So we can do this and we can say, well, yeah, let's factor out v of x. We're going to get g of x plus delta x minus g of x, close the brackets, over v of x plus delta x multiplied by v of x multiplied by delta x. So here we can actually cancel this and this out, right? So let's cancel them out. So this goes away and this goes away. Let's write the limit. And let's simplify the second equation as well. We're going to get g of x factored out into v of x minus v of x plus delta x, close brackets, over vx plus delta x multiplied by v of x multiplied by delta x. Great. So here we go. So what we can do here is we can factor out a negative from this, can't we? So let's factor out a negative. We're going to put the negative outside, and this becomes a plus, this becomes a minus, right? So let's just rewrite it. So it's going to be vx plus delta x minus vx. Good. Let me scroll down a bit so I can continue. Now here, let's apply the limit. So we're gonna have this. I'm gonna split this, and we're gonna get g of v of x plus delta x minus g of x over delta x, right? I just split fractions. So as the limit of delta x goes to 0, here delta x becomes 0, so we're gonna get 1 over v of x, right? And by definition, when delta x goes to 0, this is just the derivative of g with respect to x, right? So here's the first fraction simplified. So the first fraction simplifies into g prime over v of x, right? Plus, we have the limit as delta x goes to 0. We don't write the limit anymore here because we already used it up, right? So now let's simplify this fraction. So what happens? The limit here. So as this goes to 0, we're left with, in the denominator, we're left with v of x multiplied by v of x multiplied by delta x, right? And of course, this fraction from here to here is just equal to, we have minus g of x here. This is just equal to the derivative of v, right? When the delta x goes away, right? Because this whole fraction from here to here just means the derivative. So this simplifies into, if the limit is applied, it simplifies into minus g of x v prime x over v squared of x, right? We already applied the limit, so we can remove it. Okay, great. So now we have this function plus this function. What can we do? Let's simplify. So how do we simplify functions? We need the same denominator, right? So here in this function, we just multiply by v of x, right? You're gonna get v squared of x plus minus g of x. We don't change anything in the second fraction because, you know, we still have the same denominator. And now we can simplify. We're gonna get v of x g delta x minus gx v prime x over v squared of x. What does this look like? Well, this looks like the quotient rule, which is exactly what we learned over here. Where is it? Yeah. This whole thing right here. You see that? I just proved it, and hopefully you understood. And this is just some weird retardism. Good enough? So now let's do some exercises and examples so you guys can get the gist of it. So here we go. Let's go to page... Let's do activity on page 52. We have y is equal to x cubed plus 1 over x squared plus 1. You have a fraction. If you have a fraction, then you have to use the quotient rule. That is by definition the quotient rule. Let's state it. If y is equal to vx gx, then y prime is equal to vx gx, then y prime is equal to, guys, bear with me, the derivative of the first function multiplied by the second function minus the derivative of the second function multiplied by the first function over the denominator squared. Okay, so now let's label our functions. How about we let the numerator be v of x and the denominator be g of x, right? So v of x is equal to x cubed plus 1. So v prime of x is equal to 3x squared, right? And g of x is equal to x squared plus 1. Then g prime of x is equal to 2x, right? So all we have to do is literally substitute. So y prime is equal to v prime of x, 3x squared, multiplied by g of x, which is x squared plus 1, minus g prime of x, which is right here, 2x, multiplied by the first function, which is v of x, all over the denominator squared, x squared plus 1, all squared. And that is your answer. You can obviously simplify it, but I'm not going to simplify it in this video for reasons. No reason, guys, but it takes way too much time. So now that you've got the quotient rule, we're going to move on to another rule. It's one of the most important rules in derivatives, and it's actually called the chain rule. If you don't know the chain rule, then basically you don't know how to derive functions. So guys, let's continue. The chain rule. So let's choose the whitest of white, because the chain rule, and highlight it, is one of the most important rules, and in this video I'm going to be teaching you what it means and how you can find it. Chain rule is all about composite functions. What are composite functions? If you remember from grade 10, a composite function, or we call it f of x, is equal to, sorry, I just needed to do that, yeah, sorry, is equal to g of v of x. That means a function in a function. G of v of x, or f of x. Okay, what does this mean? This just means the domain of one function is another function. That means the x of what, so we can rewrite this as, think about it like this. We can rewrite this as g of v, or no, not g of v, g of z, and z is equal to v of x, right? So this is g of z, which is just g of v of x. G of v of x is just another function that is created by two different functions. So let me give you an example of a composite function. So here we go. F of x is equal to the square root of x squared plus 1. Okay? So we can literally say that this is the square root of another function, g of x, and it's equal to f of x, right? And let g of x be equal to x squared plus 1. So we have one function, and we have a whole new function, which is the square root of g of x. So now, let me introduce the derivative rule of a composite function. So let me write the definition of derivative. Limit as delta x goes to 0. This is the derivative of a function, right? Minus f of x over delta x. Right, so now let's just substitute, and by the way, f of x plus delta x is equal to g of v of x plus delta x, right? So I'm just going to write this down, g of v of x plus delta x minus, okay, g of v of x all over delta x, and of course you have the limit as delta x goes to 0, right? So here I'm going to do another manipulation. This is how you solve derivative questions. You just do manipulation after manipulation after manipulation until you get an answer. Now some genius said, some mathematician said, what if, so let me just rewrite this, delta x minus g of v of x all over delta x. And what if we multiplied it by, or actually let me use dot because I don't want to get you confused. What if we multiplied it by, open brackets, what if we multiplied it by v of x plus delta x minus v of x over v of x plus delta x minus v of x. It's like I multiplied by 1, because here the numerator and denominator are the same. They cancel out. But again, this just allows us to manipulate. So let's multiply and let's see what happens. So what I'm going to do is I'm going to swap the denominators, because we're multiplying, right? We can swap denominators. We're going to get the limit as delta x goes to 0 of g of v of x plus delta x minus g of v of x over v of x plus delta x minus v of x multiplied by v of x plus delta x minus v of x over delta x, right? I just swapped denominators. Well, you can see what this just allowed us to do. What does this mean when there's a limit present? This just means v prime, right? V of x plus delta x minus v of x over delta x with the limit as x goes to 0. That's just v prime of x, right? So now we solved this part of the equation. We need to solve this part. So we already applied the limit here. So we are done with the first part of the equation, which is just v prime of x. And all we're left with is the limit as delta x goes to 0 of g of v of x plus delta x minus g of v of x over some change, actually, let me just be a bit more precise. So here we go. So what I'm going to do here is I'm going to do another manipulation. Let me scroll down. What does this mean? This is a change in the function v. This is delta v of x. So we can rewrite this as the limit. And again, this just makes pure intuitive sense. I need you to think about it so I can prove it to you. So I'm just going to rewrite this as g of v of x plus, or actually, let me give it to you another idea. Let z be equal to v of x. Good enough? We can say that. So we can also say that v of x plus delta x is just z. So it's going to be some z plus another change. Some small change in z, right? So yeah, here we go. Let's just rewrite it. The limit, and in this case delta x is represented by h, right? As h goes to 0, g of z plus h minus g of z over z plus h minus z. Right, guys? Well, what does this look like? Let's simplify the denominator. It looks like the limit as h goes to 0, g of z plus h minus g of z over h. This is exactly the derivative of g, because look, this looks similar to f plus x plus delta x minus f of x over delta x with a limit, right? It looks the exact same. Compare these two functions, these two expressions. They look the exact same. So what can we do here? We can define this as the limit of g with respect to h, right? That means if you were to plot the graph, you're going to have g of z here, and you're going to have z here, right? Instead of having g of x and x, right? And then you'll just draw the tangent, and that's the derivative, right? So here, this is just the derivative. So let's rewrite this, the derivative as, let's substitute h, let's substitute z back again. So delta x goes to 0. Now you got the general idea, right? You got the general idea. I'm just going to substitute everything back. So now we have the original equation, right? Minus v of x. We have the equation back. So we can define this as the derivative of g of v of x with respect to v. This is exactly how we define it. And then let's scroll back up, and don't forget v prime of x multiplied by v prime of x, right? Now, this seems like a hell ton of stuff to look at, right? So I'm going to give you some examples and you'll probably understand. But what does this look like? It just looks like the derivative of, so if we said that f of x is equal to g of v of x plus delta x, right? This looks like the inner function, g of x. So this is the derivative of the inner function, and this is the derivative of the outer function. And we multiplied them together, of course, with respect to v of x. So this is the chain rule, and we proved it. And I'm going to give you some examples so you guys can understand. In other words, this is equal to this by this. Well, f prime of x is just equal to the derivative of gx with respect to vx dvx multiplied by, right? Multiplied by the derivative of v of x over delta x. Now, this is exactly the chain rule. I just rewrote it again in a smaller form. Now, look at this. This can cancel out with this. It makes pure sense. We're only left with dg of x over dx. This can cancel out. It's like these two terms cancel out. And it makes pure intuitive sense. So let me do an example so you guys would understand. And hopefully you do understand. So let's say we have y is equal to x squared plus 1 raised to the power of minus 10. Let's find the derivative, which is y prime. So this is going to be equal to the derivative of x squared plus 1 raised to the power of minus 10 differentiated with respect to dx plus 1 multiplied by the derivative of x squared plus 1 with respect to x. Right? This is the chain rule. The derivative of the inner function multiplied by the derivative of the outer function. This looks familiar, doesn't it? It's like saying dx to the power of minus 10 with respect, dx to the power of minus 10. Let me write x properly. Over dx, right? So how do we solve this? We just say minus 10 x minus 11, right? This is the normal chain rule. X to the power of n, its derivative is n multiplied by x to the power of minus 1. This is exactly the case. What we're going to do here is we're going to bring out the negative 10. And we're going to say we have x squared plus 1. You're going to have negative 11. Minus 10 minus 1 is negative 11. And the derivative of x squared plus 1 is just 2x. And this is the answer. This is the answer. I'm going to do 2 more examples so you guys would understand what I mean. Okay? Hopefully you do. Hopefully you do. It's better than it's better than what we have in class. We barely proved anything. So, yeah. Here we go. So let's do example 1, page 53. Y is equal to the square root of x squared plus 2x plus 3. Right? So here we have 2 different functions, the square root of this and the function itself, which is x squared plus 2x. Let's apply the rule. Right? So we're going to have 2x plus 3, the derivative of this with respect to x squared, dx squared plus 2x plus 3, multiplied by the derivative of the inner function, which is x squared plus 2x plus 3 with respect to x, right? This again, oh my god, sorry. This again looks like the square root of x differentiated with respect to x, right? These terms are the same. Exact same. What's the derivative of this? It's going to be 1 over 2 radical x, right? Exact same thing here. Exact same thing here. This is going to be 1 over 2 multiplied by the square root of x squared plus 2x plus 3. And of course, this is multiplied by the derivative of x squared plus 2x plus 3, which is just 2x plus 2. And this is your answer. Actually, we can further simplify. We can factor out the 2 from here, right? Cancels with the denominator. We're going to be left with x plus 1 over the square root of x squared plus 2x plus 3. And this is how you use the chain rule. I'm gonna take a harder example so you guys would understand it more generally, if you will. So we have x squared over x squared plus 1. Right, guys? So what can we do here? What does this look like? Let's analyze for a bit. This is a fraction. So what do we have to use? Well, we have to use the quotient rule, which is just equal to, remember, the quotient rule is, I'm going to scroll up so I can show you what the quotient rule is. It's this rule right here. We have a fraction. We take the derivative of the first multiplied by the denominator, and so on and so forth, right? So exactly what I'm going to do here, I'm going to define the functions. So we said that if we have y is equal to v of x over g of x, y prime is equal to v prime, retarded computer mistakes, v of x, g of x minus g prime x, v of x over g squared of x, right? Well, here we go. Let v of x equal to x squared minus 1. So v prime of x is equal to 2x, right? And well, let g of x equal to the square root of x squared plus 1. And now we need to find the derivative of g of x. Now, this looks like a composite function. It's the square root of a bigger function, which is x squared plus 1. Well, how do we do that? Well, this is just equal to the derivative of x squared plus 1 with respect to x squared plus 1 multiplied by the derivative of x squared plus 1 with respect to x. It's like this and this cancel out, right? So here we go. This fraction is equal to 1 over 2 x squared plus 1. And this is equal to 2x, right? So let's rewrite it. So this is just equal to x over x squared plus 1, right? 2 cancels out with 2 here, right? So yeah, there you go. Now all we have to do is just substitute. All we have to do is substitute into this equation, right? So v prime multiplied by g of x. So here we go. V prime multiplied by g of x minus g prime x multiplied by v of x. So here we go. G prime, which is just x over square root of x squared plus 1 multiplied by v of x, which is just x squared minus 1, right? And all of this is divided by this squared, right? The square root of x squared plus 1 squared is just x squared plus 1, right? And this is your answer. Now, of course, you can simplify, and you should. So let's try to simplify here. Okay. This is going to be a pain in the, well, we're not allowed to say inappropriate words here. So let me try to simplify this. Just give me a second. Okay, so let's simplify this. So let's multiply the first term by radical x, right? Let me just restart from here. We have denominator here, we don't have a denominator here. In order for us to add them, we need to have the same denominator. So let's multiply by the square root of x squared plus 1. Right? X squared plus 1 multiplied by square root of x squared plus 1 over the square root of x squared plus 1 minus this whole expression, right? X multiplied by x squared minus 1 over the square root of x squared plus 1. Again, all over x squared plus 1. Now, since they have the same denominator, we can simplify the numerator, right? So this, the square root multiplied by the square root, is just quite literally the inner domain, which is just x squared plus 1 minus x into x squared minus 1 all over the square root of x squared plus 1 all over x squared plus 1, right? So what we can do here is we can take this denominator and put it here. This is just simple mathematics. You guys know that. And now let's just simplify the numerator. So we're going to get 2x cubed plus 2x minus x cubed plus x, right, over x cubed plus 1, the square root of x squared plus 1. Let's further simplify. We're going to get x cubed plus 3x over x squared plus 1 multiplied by x squared plus 1, and that is your answer. So until now, hopefully you understood. Hopefully you did. If not, then ask me in school. I'm just going to do one more exercise, and hopefully you should get it. It's on page 54, activity 1, number C. So let me scroll down. Let me erase this. And here we go. Let y be equal to square root of 1 plus 3x squared all raised to the power of 5, right? They're telling you find the derivative. Well, let's use a chain rule, and we can say the derivative of the square root of 1 plus 3x squared raised to the power of 5 with respect to the inner function, right? 1 plus 3x squared raised to the power of 5 multiplied by d, and you're going to see the beauty of this in a second. You're going to see the beauty of this, dx. Now, what do you notice here? This can be also solved using the chain rule. So now we're going to have three different fractions. Let's copy this fraction down, right? The square root of. Guys, I'm getting goosebumps. I'm getting goosebumps. I love this so much, guys. You have no idea. Over d1 plus 3x squared raised to the power of 5 multiplied by, let's split this using the chain rule. We're going to get d 1 plus 3x squared raised to the power of 5 over d1 plus 3x squared multiplied by d1 plus 3x squared with respect to x, right? This can be split using the chain rule. So you guys can see that the chain rule is infinite. You can keep on applying it. So for any function, we can find the derivative as long as the function is continuous. Now, you don't need to know what continuous means. The school will always give you continuous functions. But for the math enthusiasts, you should know what continuous functions are. So this is just equal to 1 over 2 multiplied by this 1 plus 3x squared raised to the power of 5 multiplied by 5 into 1 plus 3x squared raised to the power of 4 multiplied by the derivative of this, which is just 6x. And there you go. Quite literally, we just solved this question. Now, let's simplify. Let's multiply. 5 multiplied by 6 divided by 2 is just 15, right? So 15, 1 plus 3x squared raised to the power of 4 over the square root of 1 plus 3x squared all raised to the power of 5. And there you go. That's your answer. Thank you guys for watching. And as always, easy.